All right, welcome everyone. Again, my name is Jeff Barnes, Angel Investors Network. I want to thank you all for being here live. If you're watching this recording, again, thank you so much for that. And I want you guys to do me a favor. Go ahead and type in the chat. Let me know that you can hear me and you can see me and that it's all working properly in the way it's supposed to. Of course, we like to test that before we get going. The next thing I'm going to say is that because the people who are here are presenting, we're going to ask you guys to turn off your phones, turn off all of the notifications, all the noisemakers inside or on your computer, on your device, because we really want you to provide our presenters your undivided attention. We really do appreciate that. And a couple of ground rules. If you are in the audience and you are watching this, and thank you for all you guys for telling me you can hear me and see me. If you are watching this and you also have another deal that you're working on, please don't spam in the comments and ask people to look at your deal or share your contact information. Anybody who does that will be removed from the chat and not be allowed, or from the webinar will not be allowed back into this one or future webinars, okay? We do that because the folks who are on this call, who are presenting, are paying clients of Angel Investors Network. And so that we do not violate SEC regulations or guidelines, we don't allow people to just go out there and start spamming and trying to raise capital on their own for their own deals or anything like that. So please be mindful, please be respectful of everybody that's coming in. All right, now I believe that we have Harmony Turbines is going to be the first presenter. So I'm going to bring in Christopher here. So let me bring you up here. All right, Christopher, let me know if you can get in there and be able to unmute yourself. All right, everybody's saying, yep, it's all well, it's all good. And there you are. How are you, Christopher? Oh,
good.
Kylie's jumping in too. All right, wonderful. Okay, so the way the format works, just so everybody is aware, each presenter gets about 15 minutes to present and then a few minutes of Q&A. So as the presenters are giving their presentations, please queue up your questions. You can ask them in the Q&A section at any time. We're going to ask the presenters to go ahead and share their screen and they'll be able to give their presentation. The rest of us will be off of video and off of audio. And then while they're giving the presentation, of course, we're going to take notes and keep track of all the questions. Then at the very end of every single presentation, we are going to provide a poll and ask if you like the presentation, if you'd like to learn more about the company, and if you want us to get you in touch with these presenters. They're also, of course, going to have calls to action. So make sure you guys are ready for that. So, Chris, are you guys ready?
Yes.
All right. Why don't you go ahead?
It's okay.
Yep, we can hear you just fine. We can see you. Why don't you share your screen? Let's make sure that's working before I jump off here.
All right. And we also want to make sure that you'll be able to hear the volume when we have a very short video to play. So
okay, just make sure you guys are sharing sound, computer sound when you share, and you should be all set.
Is that in the more button, share sound?
So go ahead and click on the share button again and share again, and then share with sound.
Yep, that's what I've done. Okay.
All right, then you should be all set. So with that, I'm going to go ahead and turn it over to you, Chris, and I'm going to kill my video and I'll be here in the background for you. It's all yours.
Okay. Hi, guys. We are Harmony Turbines, and we are a small startup, really something that kind of began as a evening and hobby project and sort of morphed because we were sharing the journey with all of the people. We were putting posts out on YouTube and online, and after a while, people said, you've really got to take this and do something with it. So can you see my screen right now?
Yes.
Okay. All right. So what you're seeing here is our wind turbines that we're developing. We are in development right now. We are not in revenue yet. So we are an early seed company. And I want to make that clear. There's no units that you can buy right now, but we are in the development stages. And the larger one represents about a 1 kilowatt unit, the smaller one about a 400 watt unit. And the cages and everything around them are just for testing purposes. So these are proof of concept prototypes, test prototypes. Some achievements that I want to go over as we begin here. We have 2 granted patents already. So not just patent pending or anything, but 2 fully granted patents on our technology. It is both the furling technology and our Axial Flux generator that we have patented, and I'll speak to those in a minute. We've raised over 1.16 million to date, with still retaining over 81% equity for ourselves. We have about 1,400 current investors. That number just went up today a little bit more. Over 42,000 active project followers on seven different media platforms, guys. YouTube, Facebook, We have WeFunder, StartEngine. We even do TikTok, Instagram, a little bit of everything right now, but 42,000 active followers. We have 3 prestigious engineering universities that are partnered with us to actually do research on our project. We also have alliance partnerships with local manufacturing shops to help us get the pieces and parts made quicker so that we can move from one iteration to the next very quickly and in an agile manner. We have had positive team growth just this past quarter. In fact, our team has grown and we've actually hired some people onto the team. And we are working to be revenue positive by 2024. So we hope to actually be taking our first orders, our early orders for beta customers by the end of 2023 if things go well. We are in development of our Mark II minimum viable product, MVP prototype right now, and we're already designing our Mark III version. So as we see things we don't like, we kind of scrap that, redesign it, and we keep the things that we do like, and we're just basically iterating through, working through the development process to make sure that we have an efficient and functional unit by the time we're done. So you're like, okay, these are crazy wind turbines. I'm not sure, what it is that you're talking about. I will actually go into how we started here in a minute, but I want to show you a very quick video. It's 90 seconds long, and it'll help to describe better than I can what our product is and what it does. So I'm going to turn this on for 90 seconds so you can actually see it.
Harmony Turbines is a startup company developing small-scale and residential-sized wind turbines with capabilities never before seen in the industry. The following is a quick time-lapse example of several hours through a windstorm. The automatic furling capability of Harmony Turbines is so revolutionary that seeing it in action is the best way to understand just how it works. On the left, we have Harmony Turbines. On the right, a standard small-scale home turbine. When there's no wind blowing, Harmony's default state is fully open, like this. It starts spinning in winds of just 1 to 2 miles per hour, where the competition usually needs 6 to 8 miles per hour just to start spinning. Harmony then stays fully open during low and normal wind speeds, but when storms kick up and winds begin to climb to stronger levels, Harmony does something amazing. It starts automatically furling to protect itself from these dangerous winds, while other small-scale wind turbines are forced to stop to protect themselves. Harmony's furling technology allows it to both stay safe and produce full power while the wind is at its peak, delivering maximum energy through the events that other turbines are forced to waste. This clear advantage sets Harmony Turbines well apart from the competition. In fact, our technology could even become the industry standard for wind turbines of all sizes in the near future.
Okay, so that is a very quick introduction, but a great example of what Harmony is, what makes our furling so incredibly cool, and why we have patents on that technology. I'm going to go really fast through the next slides because it's just a little bit of background in our company that I want to get through. We started out in 2017, 3D printing and really just testing on very small scale to make sure that the concept was viable. That little green one is the very first unit that we actually 3D printed. Our first patents were granted July of 2020. The second patent was granted in October of 2021. And again, it is on both the furling technology that you just saw and our axial flux generator with the first of its kind variable air gap. The variable air gap in our axial flux generator is a whole new concept. So basically, if you know anything about engineering principles, you've got your magnets in these upper and lower platters, and then you have your coils in the middle. The coils are what pick up the magnetic flux as they spin, as the turbine rotates and creates electricity. We overcome the initial startup reluctance, the initial startup cogging and lockup problems that other turbines face by basically starting with our air gap fully open so that there is no resistance there. Then as Harmony begins spinning and getting up to speed, you kind of get the flywheel effect going. We begin moving those platters down into proximity of the coils where we start generating power. And then when we're at a minimum desired RPM for full engagement, the platters are fully engaged. At that point, the picture on the right looks like all of the other axial flux generators out there on the market. But what Harmony has that no one else has is the ability to look like this on the left before things even get going. This allows us to actually use solid core coils, which are much more power dense than air coils. And the industry at large, the units that are out there, they're solving the problem of startup, cogging, and reluctance by using air coils. So we're using solid core coils. We're engaging both the north and the south pole at the same time, and our variable air gap technology to do some amazing things that have never been done before in the industry. Okay. Our current facility is about 3,000 square feet. We have 2 CNC machines. We have 2 vertical mills, manual ones. We have a horizontal manual mill. We have a lathe. We have dedicated welding, both steel and aluminum fabrication. We've got a small electronics area and an area for setup. These are just some pictures of our setup in Lebanon, Pennsylvania. Here's our 3 project partnerships that we have with Bucknell University, Penn State University, and Northumbria University. We actually got letters from 5 engineering universities. 2 that aren't mentioned here are Thomas Jefferson and Villanova University that actually wanted to partner with us as well. When they took a look at our technology, they were blown away and immediately submitted proposals to do projects on our technology. So we pared it down to 3. Bucknell is looking at individual unit performance at the turbine level. So they're doing small wind tunnel testing, and then they're doing full-scale unit testing up on their engineering roof. Penn State is doing ganged testing, where they're taking 10, 20, 30 little tiny turbines and testing them in a water tank facility to see how they perform in close proximity to one another. Oxford University released a study back in April of 2021 stating that they're actually 15% more efficient when vertical axis wind turbines are placed in close proximity to one another. And that is a whole new paradigm in and of itself, because now we don't have to put our turbines way far away from each other and space them out. They actually help each other with production. Northumbria is doing computational fluid dynamics and calculating to help us get a better scoop performance, a better airfoil, and help us tweak our design at the individual blade level. This is a picture of our Dr. Azar Panah, who is in charge of the water tank facility, and she's the PhD in charge of the project there at Penn State Berks. This is where we were at Northumbria. This is their, I'm sorry, Bucknell. Thank you. When we were there visiting, and this is their wind tunnel. So the small units that they're going to be testing for Harmony in the wind tunnel. And then I took out the picture, but the up on top of their engineering building is where they're going to be mounting a full-size unit for the hard point testing up there. Project partnerships with Steel Design Manufacturing in Lebanon, PA. This is Mike Glant, and behind him, his water jet capabilities are absolutely phenomenal there. So we're partnered with them to get our 2-dimensional parts produced very quickly and efficiently with their help. They also do rolling and welding and crimping and other things that we have need of in our designs. Our 400-watt kit pretty much looks like this. These are CAD renderings of the design, and our goal is simple. We're trying to create an affordable, easily shipped kit with simple modular components for global distribution. Something that has really never been done before in the industry is giving people a product that they can truly be happy with, that truly makes sense all around, and in so many ways does what everyone is kind of wishing that the turbines that are out there on the market could actually do. Our goal is to achieve those convenience, ease of use, simplicity, you know, not having to put it 90 feet up in the air on some crazy pole. Some shots of very recent production where we were producing parts. These come out of our CNC machines. So these are a whole bunch of different types of gears that we make for our furling capabilities. These on the right, if you can see my mouse, are some of the gears that come out of the 2D water jet facility. These are some other components that we make for basically our connecting and stabilizing platforms, our furling link plates, and then the tubes that of course drive the furling up through the unit. We have a little bit of lathe work being done there by Nathan, and couple other shots of the parts that come out of the steel design manufacturing side of the house, where they're actually producing, rolling, crimping, and welding the two-dimensional parts. You can see some of the two-dimensional parts that were cut out of water jet down here, and then the finished scoops as they're welded. These larger gears are actually produced on the water jet, and then that's one of the employees there doing the welding. Here in the bottom corner, we were taking delivery of 16 of those scoops for the first 2 MVP prototypes, and the one that will be going up to Bucknell. December 2022. Wow, that was just the other day, right? We were actually putting the first MVP prototype here, the one that's going to Bucknell, together, getting it in its frame. And my son is standing there in front of it, so you can get a little bit of scale on the size. This unit is shorter than what would be for production units, because obviously if someone walked into that, it would smack them right in the head. It's shorter than that because they will be putting it on their rooftop, and it's not going to be accessible to the public. They want to have easy access to the components, to the area down below the furling mechanism, and testing and purposes that they need it to be shorter. So out in the field, units would be probably 8 to 10 feet off the ground, so that it can spin without danger of hitting anyone in the head or anything like that. At this point, I am going to open it up for questions and stop sharing my screen. Okay, I should be back to just us and Jeff.
Wonderful. Well done. So yeah, everyone, if you guys have any questions, go ahead and start queuing those up and we'll make sure we get those asked. I guess a couple of quick questions on my mind, Chris, is when it comes to your guys' overall distribution, who are your main target markets? Who are the main people you guys are going after?
Initially, we're going to be going after coastal customers because they have the high winds that are constantly available, but they also get the dangerous winds, the winds that are coming up unexpectedly and destroying the turbines that they have. We have boating and sailing customers calling us saying, Chris, when are you going to be ready with this product? I've already gone through 3 of these crappy turbines this year that I had on my boat or on my yacht. And that's because the products that are out there on the market are, you know, woefully inadequate for what they really need. So they're waiting for a better product like what we can deliver.
Yeah, absolutely.
Well, so getting the full amount of funds allows us to hire more people and get some better equipment so that we can get the job done faster, because we have a lot of iterating we need to do. We have a lot of things going on. So we, like right now, we're about to make an offer on an admin position, and we have a machinist job and an engineering job coming down the pike here. So we do think this to it will help us get through the iteration process faster. It lets us get data from the universities that are doing the testing for us, and lets us get into a beta test position where we can start taking pre-orders for the beta units and, you know, low volume production. It puts us in a revenue positive position. So we believe that it will bridge that gap for us.
Wonderful. Okay. So that leads into another question here, which is how long does it usually take to build a single turbine? And what about getting into a higher capacity turbine?
We are already talking with a number of people on groups that want to build 1 kilowatt, 3 kilowatt, 6 kilowatt units. And those type of capabilities will be probably something we license to several different manufacturing companies. We also have companies contacting us asking if they can license the rights to make smaller units that would be appropriate for RV and boating purposes. So how long they take to make an individual unit is really, when you're prototyping, everything takes longer when you're prototyping. It costs 10 times more when you're prototyping. So it's not a great indication of how fast we'll be able to do them in production. But if you have all the pieces and parts made, you literally can put these together in just a matter of a day or two. It's really making all the parts that takes a while, but high volume production, plastics manufacturing, composites, things like that make all kinds of things happen with moving quicker and getting more throughput.
Absolutely. All right, wonderful. You also answered another question here, which was, are you going to be able to license them? It looks like you guys will.
Yes.
Just in the interest of time, I want to try and get through these last ones pretty quickly. So you talked about 2 different sizes that I heard, 400 watt and a kilowatt unit. I'd imagine those are going to be your main production ones initially. But if you guys are having different ones, that's, let us know about that. And what is your target retail price for these units?
So our initial flagship product is really just going to be the 400 watt unit, something small enough that we can ship them anywhere in the world, that people would be able to handle them on their end. If we go larger than that, people would need forklifts or trucks or cranes on the other end, and it complicates things. So we're trying to launch with a product that is smart, intelligent, convenient, and easy enough that people can do it themselves or with a buddy or two to help get it set up. The price we used to be saying was we wanted to sell these things for $2,500 a pop, but manufacturing has gone absolutely crazy, Jeff. Over the past year alone, things have tripled and quadrupled in price. So at this point, I'm not even guessing. We're just doing the best research and development that we can. And when we get to the point where we're now saying, okay, now we're ready to go into production, we'll look at ways, everything that we can do to bring the price down to a reasonable amount so that people, as many people as possible, can afford them. You know, we're not looking to gouge people for these. We're trying to get the technology out to make a difference in the world.
Yeah, absolutely. Well, and I'd imagine that it'll be similar to solar, like a lot of governments have done around the country, where they will subsidize in some way. So
Correct.
of course, getting grants and getting things like that will help out for sure. There is a question here about wildlife impact. I know you guys didn't, but if you can answer that maybe in the next 10 seconds. Have you guys done any wildlife studies, or think there will be any impact on wildlife?
Some of the universities have spoken to it, and it is an entirely different design that has little to no chance of harming any animals. The way they're killed with the large, huge wind turbines that are out there is the birds are looking forward and they're looking down as they fly, and those blades come in out of nowhere. They move 200 feet in a half a second, and they hit them on the back of the head and knock them out of the sky and kill them. With Harmony, it's a solid object rotating slowly in front of them. They will see it just like a house, just like a grain silo, and simply fly around it.
Perfect. All right. With that being said, I want to thank Chris and I'm sorry, Cheryl and Cheryl for being here with us today and giving us an incredible presentation, really incredible technology. There's another question. We'll just go ahead and send this over to you, Chris and Cheryl, so you guys can review that. If you guys haven't already, please answer the poll. We'd like to know if you guys are liking the presentation you're seeing, if you'd like to learn about the companies themselves. So let's go ahead and get that answered. And in the meantime, I'm going to say thank you to Chris and Cheryl, and we're going to bring on our next presenter here.
Thank you.